Hello and welcome to another video. In this video we're going to be working on palindrome partitioning. And in this one you're given a string S and you want to partition it such that every substring of the partition is a palindrome. Return all possible palindromes. So in here, essentially there's two ways to do it. So it's either AAB or AAB. You can't have something like this because this wouldn't be a palindrome. And for A it's just like this. So you can always partition it into one letter palindromes, right? So even if you had like all unique letters, there's always a way to partition it into palindromes because you can just make them all one letter. But essentially, this is pretty similar to the last couple problems we did where essentially we have to kind of brute force every single possible palindrome. And for every letter, we have a choice. We can either put it in the word before or start a new word, right? So if we have a word like let's just say we have some string, like, let's get rid of this, actually, we don't even need this anymore. Okay, so let's say we have like something, let's do this, there we go. So let's say we have like A, B, 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 C or something. Essentially, for this first letter, we have a choice. We can either put it in the previous word or start a new word. So in this case, there are no words, so we'd have to start a new word. But then when we go to the next letter, we can either say like, okay, let's put it with this A, or we can start a new word. But you also have to enforce the palindrome. And so there's kind of two ways of doing this. You can do one, you can do this, right? And then later on, once you made all your words, check, is every single one of them a palindrome? But you're basically going to have a lot of cases where you have errors, right? Like let's say I tried like A, B, 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 and like maybe this. This is the combination I tried, and then now I have to check is each one of these a palindrome. Or a lot of these, like, you didn't need to go here because this is already not a palindrome. So the better way to do is only use words that are a palindrome right away. So instead of for every letter, do I say put it in my word before or make a new word, I'm only gonna take words that are valid. So instead of going for every letter, I'm gonna say for every word, take all valid words. And this will make it a lot more efficient. So what we're going to do is, like, in the beginning, we'll start over here and we'll say, okay, let's try every single possible word we can have, and then we'll recurse. So for example, we can have an A as a word, and then we'll recurse to here and we'll start a new word. Or we could have had AA as a word, and then we'll recurse to here and then we'll start something. And then nothing else would be a palindrome. But let's say, for example, we have A's over here. So you can see how like AAB would not work, but when you actually get all the way here, this whole thing would work. So that's why for every index, we're essentially going to try to build all valid words we can, and then it recurs to the next index, and then we're going to backtrack back and then delete the word. So that's the strategy we're going to use. So we're going to make a function that's going to check for a palindrome. That's pretty easy. And then we'll do the same template as we did in all the other problems, where essentially we're going to be at an index, and we're just going to start at an index, go all the way to the end of the word, and we're going to check, like, is this current thing a palindrome? Like, is this a palindrome? If yes, we'll try this. If this is a palindrome, is this a palindrome? Is this a palindrome? And so on. And if something is a palindrome, then we'll start at the next index, and then we'll do the same exact thing, and so on. That way we can just get rid of all the cases where like a bunch of middle words aren't palindromes, and this will be a lot faster. Okay, so that's what we're going to do. So same kind of things as the last couple of days, same kind of template. So we'll have a list string result. Yeah, so we'll have this, it's capital. So that's the same, and then we're going to have a list string current, which will be like our current subset or something, right? Same thing literally as the last couple days. Then we also are going to make like an isPalindrome function. And so with this, we're just going to take, we can do one of two things. We can either take a string or check if it's a palindrome, or we can take indices. So we'll just use indices because they'll be a little bit faster. So instead of building the string every time, we'll just take indices and then check. So we'll say private boolean is palindrome, and it will take two indices, so int left, int right, and the string. And we're just going to check, is this a palindrome, right? So we can just say like while, like a normal palindrome check, while left is less than right, we'll check if s character at L does not equal s character at R, return false, increment them both, and return true. Okay, so yeah. So that's done. Now we're going to write a backtrack function that we'll just call up here. So very same thing as last time, or as all those couple days. All we need is an index and a string. And here, so like I said, what we're going to do is we're going to say, if we've reached the end of the word, then we'll just take our current subset and we'll put it in the result. So we'll say, so we'll say if I equals length of s, or I guess it's like this, then we'll just say, let's just take this subset and put it into the result. So we'll say result dot add new array list. And yeah, if you compare this code to yesterday to the day before, it's almost all the same with a few changes. So we're just going to take our subset and make a copy of it like this. And I talked about why this was yesterday, because essentially we're going to modify our subset. So we need to put in a copy into the result, because if we just put in our subset and we modified our subset, then it would also basically always get deleted. So we need to take a copy and we can return. Otherwise, we're going to start at some index, and then from that index all the way to the end, we're going to take every single palindrome we can, put it into our subset, and then recurse to the next index. So we'll say for int I equals, or j equals I, j is less than s length. So we'll say if is palindrome, and this should be, so the left is going to be I, the right is going to be j, and the string s. So if this is a palindrome, then we'll take this and we'll add it to our current subset. So we'll say subset add s substring, and this should be from I to j plus 1, I believe. So there we go. Okay. Yep. So if this is a palindrome, we'll try to add it to our subset. We will backtrack to the next index. So if we have the substring from I to j, then we'll backtrack to j plus 1. Then after we return, we need to clean this up. So we need to also pass a string. So after we return, we need to clean this up. So essentially we're gonna add our string, then we're going to recurse, then we're gonna pop our string. So we'll say subset remove last. And yeah, if you are having trouble with these problems, just look at like the last 3 or 4 videos I made. It's basically all the same thing, and you'll have a lot of practice doing this backtrack template. The template's all the same for almost all of these. So essentially what we do is we check if our subset is valid. If it's a palindrome, we'll add it into, or if our word is a palindrome, we'll add it into our subset. We'll go to the next index, then we will remove it, and we'll keep trying more subsets. And so when you start at this index, so essentially we're going to try every single palindrome we can, and every single recursion we can. So basically a brute force. And then that's all. So now all we have to do is call this function. Oh, we need a couple more things. We need to actually initialize the result. So initialize the result and initialize the subset. Okay, now all we have to do is call our function, starting with 0 and the string s. And return result. Okay. So yeah, literally all the same. Some things you can think about. So let's say this palindrome operation was expensive, so this will actually speed it up if you did this. It wouldn't speed it up much though, because this is still going to be the same time and complexity, but in practice it might speed it up. So this is palindrome thing might get calculated, because if you think about it, you have 2 to the n different like substrings or subsets you can build. I talked about this yesterday. Essentially every letter you have a choice of put it in the previous word or put it in the new word. So that's 2 to the n different subsets you can try. So you're going to be calling this function a lot. So if you have 2 to the n different times you'll call this function, let's say, the most palindromes you can actually check is n squared, right? So because you can only have n different lefts and n different rights, right? So because n squared is less than 2 to the n, you can cache this as palindrome function. So what you could do is you could like store the results in a cache, and then you can cache that, and then most of your palindrome checks will be O1. It doesn't really matter too much here, but you could do that as well if you wanted to. So that's like a slight optimization that you can try on your own, and that would speed it up a little bit. But yeah, so this solution, essentially, like I said, for every letter we have a choice. Do we put in a new word or in the same word? And then also for every single word we try, we have to check if it's a palindrome. So essentially, we have 2 to the n different things we can do. Obviously, a lot of these, it's going to be a lot less than this, because the way we're doing it here, we're only putting in valid words. So it's going to be less than this. But worst case, it's 2 to the n. And for every single word, you have to check if it's a palindrome, which is open. So it's something like this. Space. Yeah, probably like 2 to the n combinations. Like I guess worst case, now that I'm thinking about it, would be if your word is just like all like A's or something. Then you'd have 2 to the n space. So actually, no, you wouldn't have 2 to the n space. Sorry. So your result doesn't count as a space. Like you have to build the result, so that doesn't count. So the only thing you're actually building is the subset, which is O of n. So it's gonna be like this, because your subset can only have all the letters in the word, which is like 14 letters or something. So that's O of n. But as far as like the actual runtime worst case, yeah, if you did have, the thing that would take the longest would just be a bunch of A's. And that's where the caching would help. Like if you try this out on a test case where it's like all one letter, every single thing is a palindrome, so that would take the longest. But yeah, that's going to be all for this one. Hopefully it's helpful. If it was, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.